this off in just a minute. I was wanting to show you that that is boiling, and that's like pretty hot. I've not had it on that long. What I want to show you here is the voltage of the battery and what it's feeding into it. In essence, let's shut this off now. Come on, I know it's there. There we go. Sorry about that, y'all. I knew it was there. I was just trying to put his load test as much as I had. I had the only thing bigger that I had is a belt sander, and when I picked it up, it made a big old cloud of dust, and it was like, oh no, I'm not that dedicated or whatever. I can't go that far. Here we go. Let's back that out a little bit. I just wanted to show you that even with a kilowatt, I wanted to show you what over a kilowatt looked like. And on that, there we go. There's roughly a kilowatt. We were about 1.2, and it's not feeding in. Well, it's feeding a flash into the battery every once in a while. But what I'm trying to say, the batteries are full, and that's what the solar can do. It just switched back over to the battery voltage right there. So it's hovering with that little 0.4 that it gave it. It's just giving like the top of the battery or whatever they call that. There's a name for that. Equalization, something, there's a name for that, and that's what it's doing there. There's no real amperage going into it, like nothing is what I'm trying to say. It's making 203 volt on the solar, but without a load that really doesn't go anywhere. It'll just, it goes into limbo. That's why I did the hot water element, and it actually has enough power to run 2 of these. And that's like really hot. That steam coming off there. And it's getting with it, is what I'm trying to say. If that was in, I got a tank ordered, a GE tank, with a 120 element. I don't know what size it is. But it don't matter, really, is what I'm trying to get at. This inverter here can go up to 3,500 watt. But there's a second port that's actually governed by voltage points on here, and that's why I was trying to show you the voltage on the meter originally, is because if it drops below 6 volt, let's say on a cloudy day, if it drops below 6 volt, it'll shut off the element here that I have down there, and if it goes above 27, it'll restart the element, and then it just draws. But I was getting at is with my old solar, is I only have 6 of them in one string for this, and it's still producing enough to run 1.2 kilowatt, almost 1.3. But before it's not taking anything from the batteries when it's straight off the solar. I just don't have anything more that I can add to it, is what I'm trying to say. Otherwise, I would have. I don't know what the limit is, but so far it's 1.3. And that's quite a bit to be directly converted into electric. So I'm just saying, this new technology is what you want. You don't want nothing like this old jazz like that. Or this is a workhorse. This beast can do things that are still amazing. It's almost as good as this. Let's see. Poof, there we go. It's almost as good as this one. As far as performance and stuff like that, is I had these leads transposed the other day, and I was measuring the voltage, amperage, going in, blah blah blah, and they work actually quite well. Do they work even with each other? No. This can do more with like early morning and stuff like that. Or I said that wrong. I pointed at the wrong one. This can it does more early morning and everything. This one, and I mean, like before the sun was up, I had one of those mornings I was up I went to bed early so I could get up early or in the middle of the night to do all this high voltage cutting and crimping and shrink wrapping and all that jazz, getting it all hooked back up before daylight came. Not because I don't have breakers, I don't trust them. they die, okay? And if you're messing with high voltage DC, so will you. If that breaker fails, you don't make it. I mean, there is no pass go for high voltage DC. Don't play with it. Research it. It's not like just insanely dangerous, but respect it beyond any kind of respect. Put in all the breakers, all the disconnects, all the whatever you got to do. I'm still waiting on the two breakers here, but this is only 28 volt. That's not deadly. Anything over 50, and that's these coming in out of the wall. This one is 204, and this one is 107. So this, if you grab a hold of it, you won't let go. It's just that simple. It's direct current. Alternating current, that's why it zaps you. One bite is you're grabbing down, and the second bite is blowing you back, and by then it blows you off. But the DC, you grab onto it and it just cramps down, and you can't let go, and then your heart dies. So, but don't mess with high voltage DC for like no reason. And respect it by the best wires, like I said before in other videos. And like this is that silicone rubber, the insulation. It's the fine wire, so it bends and all that. It's marine grade. Oh, that is like, there we go. It's boiling right here in our video time. So that's plenty enough heat to put into a floor, is what I'm trying to get at. If it can literally boil a pan that's half gallon, it could boil, like, really make hot 10 gallons fairly quick. Really hot water would make the concrete extremely hot, even on a sunny day, and when you could coast through the other days, just light a fire. I already light a fire, I'd just be lighting a lot less. So that was what the whole video was about. We were waiting to get to this part right here. Alright, y'all. Talk to you then.